Okay, let's put ourselves on the front lines of a public health emergency. A dengue fever outbreak is starting to spread and we need to move fast. Today, we're going to build one of the most critical tools you can have in that fight, a really smart digital case investigation form. So let's get right into it.
So picture it. Cases are climbing. Every single hour counts. You've got teams out there on the ground. But what is your single most powerful weapon? I mean, is it medicine? Is it more people?
Nope, it's information. And more than that, it's clean, fast data. Think about it. You can't fight what you can't see, right? Knowing exactly who is getting sick, where they are, what their symptoms are, and getting all that info in real time, that is how you stop an outbreak dead in its tracks.
And that really brings us to our first big idea here. This is a race against the clock. Every single delay, every little mistake, it just gives the disease a head start. And historically, the biggest bottleneck has always been getting good, reliable information from the field back to the people who need to make the decisions, fast enough for it to actually make a difference.
And this slide, wow, it really lays it all out. On the left, you've got the old way. We're talking paper forms. Just imagine trying to read messy handwriting or dealing with pages that got soaked in the rain. And then someone has to manually type all of that into a spreadsheet for days. It's slow, it's packed with errors, and by the time you have the data, it's already old news. But now, look at the right. This is the new way. Digital forms, right on a phone or a tablet. The data is instant, it's accurate, it feeds right into a live dashboard. We're talking about getting insights in minutes, not weeks.
Okay, so how do we actually build one of these things? Well, it all starts with a solid blueprint. It's just like building a house, really. You need a good foundation. And for us, that foundation is a well-structured form. Because if your questions are confusing or all out of order, guess what? Your data is going to be a mess too. So for our dengue form, we're going to keep it super clean and logical, broken down into 4 main sections. First up, case identification. Simple enough. Who's the patient? Then we move on to symptoms. What are they actually feeling? After that, exposure. Where could they have possibly been infected? And finally, location. Where do they live? This is key for mapping out potential hotspots. This whole structure just guides the person in the field and makes sure we don't miss a single critical detail. All right, we've got our structure. Now let's talk about the building blocks for each section. This is all about choosing the right type of question for the kind of information you're trying to get. And honestly, this is where digital forms just blow paper out of the water. So this table here is basically our toolkit. Let's break it down. For something like patient gender, you only want one answer, right? That's a single select. Easy. But for symptoms, well, a patient could have a fever and a headache and joint pain. Multiple select lets you check all the boxes that apply. For patient age, a numeric field makes sure no one types out the word 25. We just get the number. And a date field, it guarantees the data is formatted the same way every single time. Just choosing the right tool for the job here is your first line of defense against bad data.
But we can get even smarter than that. See, it's not just about making it easy to enter good data. We want to make it hard, practically impossible to enter bad data. This is where we start building some real intelligence into the form. I like to call them digital guardrails, and they stop errors before they can even happen.
So how do we do that? We use something called a validation rule. The best way to think about it is like a little automatic fact checker that lives inside your form. It's just a simple piece of logic that as you're typing is constantly checking to make sure the data makes sense. And if it doesn't, bam, it flags the error right there on the spot so the investigator can fix it immediately. Here's a perfect, super simple example. The rule says the symptom onset date can't be in the future. I mean, that makes sense, right? You can't have symptoms tomorrow. It sounds really basic, but you'd be surprised. In the middle of a hectic day in the field, it's so easy to make a typo. This one little guardrail just stops that kind of critical error from ever getting into your system. And these rules can get way smarter too. They can actually enforce protocol. Look at this one. If patient age is under 18, guardian consent must be marked as yes. So the form itself understands that if you're dealing with a minor, you have to get guardian consent. It's a critical ethical and legal step. The investigator literally can't move forward in the form until that yes box is checked. So now we're not just talking about data quality. We're talking about making sure people follow the right procedures out in the field. Which, brings us to a really crucial point. You can have the most perfectly designed, smartest form in the entire world, but it's totally useless if the people in the field don't use it correctly. The technology is only ever half the solution. The other half, that's the human element. You need a clear, simple protocol that connects this awesome tool to the people who are actually using it. And that protocol, that's usually called a standard operating procedure, or an SOP. It just covers the basic human steps that the tech can't do for you. Things like always get the patient's consent before you even start filling out the form. Follow the steps in the survey exactly as they're laid out. That way, every interview is consistent. And this one is huge. Sync your data to the central server the second you're done. That way, the information is instantly available to the entire response team.
So let's recap. We've just designed a tool that delivers clean, fast data. How? By using a logical structure, picking the right question types, and building in smart guardrails. Then, we connected that tool to a human protocol to make sure it actually works in the real world. This whole approach can totally transform how we respond to something like dengue. And that just leaves us with one final thought. If we can do this for fighting a disease outbreak, just imagine, where else could this kind of smart, fast data collection completely change the game?